So I mentioned this yesterday. I mentioned that generally the absolute value function takes on this form x minus h plus k, like this, and the vertex, which is that point that it v's at, is at h comma k, and then a tells you whether it opens up or down. Okay, and then we can set it equal to a number. And that's what we're doing. That's what we're doing last time, I guess yesterday, and solving for this. So let's just start with a very basic absolute value function. Let's say it's absolute value 4x minus 3 minus 7 equals 8. So as a reminder, we're going to do some different stuff today. We won't focus so much on fractions. As a reminder, you first want to isolate the absolute value when you're solving these types of problems. Okay, so you don't do anything until it's isolated. So you're gonna add 7 to both sides. 4x minus 3, absolute value equals 15. Now what's really important here is that this number, when you solve for the absolute value, must be greater than or equal to 0. Okay, so we'll look at an exception at some point, but the absolute value can only equal 0 or positive numbers. So from yesterday, you know now, you write 4x minus 3, exactly what this is, equals 15, and then 4x minus 3 equals minus 15. Okay, and you solve same steps. You want to kind of do them simultaneously. 4x equals 18, 4x equals negative 12. Divide both sides by 4. So x equals, and then you can divide 18 and 4 by 2, so that's 9 halves, and then negative 3. All right, so let me just have you try. This is the key step here. Again, just as a reminder, you set whatever's inside the absolute value equal to the number, and then equal to the negative of the number. Okay, so let me have you try solving one here. Let's go absolute value 9x minus 4 minus 6 equals, let's go, sorry, just losing track here. What I want to give you. Eight. Let's do that. Okay, could you solve for x, please?
X equals 2 and x equals 10 ninths.
X equals 2 and x equals 10 ninths. So the 2, I'll just check here. 18 minus 4 is 14. Yeah, that works. Then 10 ninths. 9 minus 4. 5. So the second one, it is not right. There's an error here. Let's just take a look here. So it's absolute value 9x minus 4 equals 14. So I hope you wrote 9x minus 4 equals 14 and 9x minus 4 equals minus 14. You're adding 4 to both sides. So the time savings technique here is you're adding 4. You don't need to write that. You can write 9x equals 18. 9x equals minus 10. So there, I think there's the issue there. It's a negative, not a positive. Maybe you said that, but I didn't catch it.
Yeah.
But again, in time savings here, you don't want to write divided by 9. You just want to know, okay, I'm dividing by 9, so it's 2. Dividing by 9, so it's minus 10 ninths there. So that will do it. Okay, great. So let's move on to kind of another thing related to absolute value. So I've mentioned this a few times. Okay, well, the formula is x minus h plus k. But what if I give you something like this, like minus 2x minus 8 plus 7? And I ask you for the vertex. So this is a more complicated thing, but this is something we do want to look at. So notice there's a 1 in front of the x in the formula up above. So
Mhm.
how do you get a 1 in front of the x? Well, you're going to factor out -2, whatever this number is, from both of these, like this. So that -2 comes out. If you distribute it in, you get back to minus 2x minus 8. Okay. So
Okay.
why did I do that? Well, there's this property now that says if you have the absolute value of A times B, this equals the absolute value of A times the absolute value of B. So why does that matter here? So this line right here becomes the absolute value of -2 times the absolute value of x plus 4. Basically, if there's a product, which is what that is, you can separate it out. So why is that important? Because the product, this right here, becomes 2. You can take the absolute value plus 7. So yeah, that 7 comes down. And now it's in that form that you want, that x minus h with the a out front plus k. So we'll do a few examples like this, but the value of a is 2. The value of h is -4 because it's the opposite of this right here, and k is 7. Okay, but the key thing, and this is what I wanted to show you, this is really important in these absolute value problems, is this property right up here. Okay.
Okay.
Now just to kind of, but before we do another example, I want to show you that is the case here. Let's take a look at something like this, like the absolute value of -36. Well, the absolute value of -36 is really -6 times 6. The absolute value of -6 times the absolute value of 6. It is 6 times 6, which is 36. And you probably know, okay, that's 36, but it does work. It works. This is just an example. It's not a proof, but it's to try and prove it to you here. So, all right. So now let's go back and do some problems. So let's say I give you the absolute value of -4x minus 12 plus 3, and I ask for the vertex and the value of a. What you have to do is say, okay, I've got a -4 in front of the x. So I'm going to factor that out first. And if it's a negative, it changes the sign of this here. It's still in absolute value.
Okay.
So this is where you probably haven't seen this before, but it would have helped us in some of those problems we were doing yesterday. Absolute value. You can now break this apart. So okay, it's -4 absolute value x plus 3. And you might be asking, well, why aren't the parentheses there? You can put them there, but the absolute value kind of already have them. Okay. And so the absolute value of -4 is 4. Okay. And so you can now tell me the value of a, h, and k. A is 4. H is always the opposite of this, -3, and then k is 3 because of this over here. And the reason this is so nice is you can then do a quick sketch of the graph here. So it's left 3, up 3, and then it's going up like this, something like that. Okay.
Okay.
So let me have you try one now. Won't make it too difficult. We'll go absolute value, -2x minus 6 minus 1. And what I'm looking for is the value of a, the value of h, and the value of k. So take a look at that and see what you come up with, please.
Okay.
Hey, Julia, have you been able to work through this, or do you still
Hi.
need more time? How are you doing on this question? How are you doing on this one, Julia?
I finished it.
All right, so did you get A is 2, H is -3, and K is -1?
I got A is -2, H is 3, and K is -1.
Okay, so let's factor out a -2 from both these. So that becomes X plus 3, like this. And this is a
Uh-huh.
really important skill because you're going to get problems where you have to either factor or distribute a negative, and they're going to look for that. So it becomes the absolute value of -2, absolute value of X plus 3.
Oh, okay.
Okay, and that's why it becomes positive here.
Yeah,
So
okay.
2 absolute value X plus 3 -1. Okay, so let's look at another problem here together. So this time I'm going to put a -2 on the outside, -3x minus or plus 15 this time, -1. Okay. So again, like we really want it in this form, and it becomes -3 parentheses x minus 5 this time. Again, I'm just factoring out of both of these right here. And this is something you're going to see like in a lot of different questions. You got to be comfortable factoring out. It's still absolute value, bringing the -2 down. Okay. So this part inside the absolute value, that's what you break apart. It's -3 absolute value x minus 5, and then you bring this -2 down. So now the absolute value of -3 is 3, but you're multiplying it by -2. That's why it stays negative. Absolute value x minus 5 minus 1. So now the value of A is -6. The value of H is 5, and the value of K is -1. Okay, so the only thing I did in this problem that's different than the others, I just added a number on the outside. I also made this positive instead of negative. Before I have you do one like this, let me give you one more like you just did and see if we can get you to knock it out here. So let's go -4x plus 16 plus 2. And I'm looking for the values of A, H, and K. How are you doing on this?
I think I got it. I just have a quick question.
Of course, go ahead.
So when I factored it out, I got 2x minus 8 in absolute value. So the
You've got
value
this.
of 8.
Yeah, let me jump in there. You've got to fact like it's got to be this entire number. You can't do. I think I heard 2.
Oh,
It
okay.
you have to get a 1 here. That's the whole point when you do this.
Oh, okay. That makes more sense.
So go ahead and rework it and see if you can come up with the values of A, H, and K, please.
Okay.
Do you have some numbers for me on this one?
Yeah. Okay. So for A, I got 4.
Good. Good. How about for
For
H?
H, I got 4 as well. And then
Yes.
K, I got.
Perfect. Okay. Now, why, that's great because the reason we're doing all this is you want to quickly get a graph of this. So the HK is the most important thing. That tells you where you're starting. There's HK, or oops, that's not the right place. HK is there, 4, 2. And then the A tells you that it opens up. Okay. So does this have any x-intercepts? Does it ever cross the
No.
x-axis? No. Excuse me, does it have a y-intercept? And before you answer, these always have a y-intercept. So the answer to that is always yes. Absolute value functions always have a y-intercept, but they don't always have an x-intercept. Okay. So what, like, when you look at this graph right here, let me actually redraw it slightly better here, because this is kind of the extension, and this is what I wanted you to really, this is really what I wanted to get into with those problems from the other day. So there's that, and then here's this, and here's this. There's 2 more points. So this is what the function looks like. What could you do to transform this function? And your options are up, down, left, or right for now. How would you move this graph so that it had 1 Hey, Julia. So what I was trying to get you to
Hi.
do or answer me is what would you do to transform this function so that it has 1 x-intercept? Where would this point have to move?
Probably 2 squares down.
Yeah, it'd have to move down 2 to give me one x-intercept. Now, if I wanted two x-intercepts, it would have to move just a little bit more than 2 down. Would you agree?
Yeah.
Yes. Okay. And that's that. See, that's your SAT question. That's kind of your like question where it says given, it would say something else. So it would say given this absolute value function, which of the following transformations would cause it to now have 2 x-intercepts Hey, Julia. So what we're trying to figure out here is like what would you need to do this function to have like 1 x-intercept or 2 x-intercepts, and sometimes they give you more. They're not necessarily mechanical questions. They're more sort of understanding questions. So let's look at another one here. Let's say I give you -2 absolute value x minus 3 plus 4. Okay. What is the vertex just looking at this? And then this one, you don't have to do any transformations. You just have to look it up. Remember, it's x minus h plus k. What is the vertex here?
I don't really remember how to do this.
Okay, so the value of h is just 3 because it's already got the same sign here. So the value of k you just read off. It's just 4.
Oh,
Okay,
okay.
so that's the v point. Now a is -2. Does that mean it opens up or down?
Down.
Down. Okay. So now quick sketch. 1, 2, 3, 1, 2, 3, 4. So this thing opens down. So here's your graph of this. And just I'll do this for now. Okay, so how many x-intercepts does this currently have, this graph?
0.
But these lines go on forever, right? Like you can imagine them
Yeah.
extending. So how many x-intercepts does it have?
Oh, 2.
2. How many y-intercepts does it have?
Maybe. So if they go on forever, would it be 1?
Yes, there's always a y-intercept. There's always a y-intercept. Okay, so this thing's got 2 x-intercepts. What would you do to this function so that instead of 2 x-intercepts, it has 1 x-intercept, meaning it only touches at one place, and it's a transformation. You have to move it up, down, left, or right. So watch this. If I move it down 4 units,
Oh, okay.
how many x-intercepts does it have now?
1.
1. And let's say I was like, nope, I want 0 x-intercepts. Well, if I want 0, that means I better move it down more than 1. Let's say I moved it down that much. Now how many does it have?
0.
Does it still have a y-intercept?
Yes.
Yes, it always has a y-intercept. Okay. Now let me just grab this graph one more time, because there's another possibility. Another possibility. So let me graph this, the original function again. I think we said 3, 4. So here's the original function. What if we were to flip it? What if it were to go the other way? Now how many x-intercepts does it have if it's going up like this?
0.
0. How many y-intercepts does it have?
1.
1. Always has 1. Okay, let's try another problem here. Let's go 3 absolute value x plus 2 minus 6. What is the vertex of this absolute value function? What's the HK?
HK. 2, -6.
So it's x minus h inside here. So it's the opposite of this sign here. So it's -2.
-2,
Negative.
-6.
Yeah. Okay.
Okay.
All right. So now, let's look at where this is graphed. So here's our graph here: -2, 1, 2, 3, 4, 5. Oop, I ran out of room. There's that point. And then what's the value of a in this problem?
3.
3. And that means it opens up. Okay. So it looks like this. How many x-intercepts does it have?
0.
Okay.
Oh,
These lines
2.
go on forever. Yeah,
Sorry.
they go.
It's
And
hard to visualize too.
I'm doing that. I'm doing that intentionally because you've got to visualize they go on forever. It's
Okay.
an important skill here. So yeah, there's 2 x-intercepts. Okay. How many y-intercepts does it have?
1.
1. Okay. Now let's say you wanted this thing to have 1 x-intercept. What would you do?
Move it up.
How many would you move it up?
7.
If you move it up 7, it's here. How many x-intercepts does it have?
Oh, 6. Okay.
6. Yeah. So if you move it up 6, it's got 1. But if you move it up 7, it's got 0.
0. Okay.
All right. So let's try another problem here. We're getting really close to sort of like formalizing these concepts, but you're doing a great job here. So let's see here. Let's go 2 absolute value x plus 1 minus 4. Give me the vertex, please.
Four.
The vertex is 2 numbers. What is the vertex in total? So it's an x and a y value.
-1, -4.
Yes. Okay, and what's the value of a?
2.
2. So does this open up or down?
Up.
Okay. So I want you on your paper there, or you can visualize it here. I want you to draw the vertex point. Draw the vertex point, and then decide which way the graph goes. We've done a couple examples like this, and tell me the number of x-intercepts.
Is it two x-intercepts?
Yes. Now it's not meant to be complicated. I mean, here's this vertex point right here, and it opens up, which means that it's going to hit each of these arrows is going to hit. So yeah, there's two x-intercepts. How many y-intercepts are there?
One.
One. Okay. All right. Fantastic. Okay. So any questions on this? I think we should transition to a new topic here.
I think I did.
Okay, so let's look at some absolute value exceptions because these are really important. And these are things you might see. So we mentioned this earlier. Let's say I give you something like this: absolute value 2x minus 1 equals 3. What are the two equations that you're going to write? Do you remember this from earlier? You just have to tell me. You don't have to solve it.
Oh, so one of them is 2x minus 1 equals 3.
Okay.
And then the other one is 2x minus 1 equals -3.
Perfect. Okay. Now that's absolutely perfect. Now what I'm going to do here is I'm going to grab this. Oops. I don't know why I did that. I'm going to grab this, and now I'm going to make a really rough sketch of what this means. So on the left, okay, on the left, this thing hits right here at 1/2, and it looks something like this. And here's the line. Actually, let me draw a little further here. And here's the line y equals 3. How many times does it hit the line? 2 times.
Okay.
Okay. And that is why there are two equations, because there's two solutions. Okay. So now let's do the next possibility. Absolute value x minus 4 equals 0. Okay. Now let's look at a graph of this. So x minus 4 looks like this. Y equals 0 looks like this. How many times do they intersect?
One.
Once,
Time.
right there. Yeah. Okay. Okay. So now to the exception. And I mentioned this when we were starting out. I said, okay, absolute value minus 9x plus 7 equals -2. Okay. Now we don't know what this thing on the left looks like, but it has some shape like, actually, I guess we can actually figure this out, but it's got some shape like this. This is the line -2. Do they ever intersect? Does this V ever hit this line down here?
No.
No. So this has no solution. And this is the graphical explanation of it. So the absolute value has to equal a positive number or 0.
Okay.
Okay. And that's the kind of the thing to like really hold on to from this lesson. Now, you got to be careful though, because let's say I give you something like this: absolute value 2x minus 5 minus 4 equals -1. You could say, hey, Matthew, there's a negative there, so this has no solution. And that is completely wrong, okay? Because you have to first solve for the absolute value.
Okay.
Okay, you have to solve for this thing right here, which means you have to add 4 to both sides. Absolute value 2x minus 5 equals 3. And yes, now you can say it has 2 solutions.
Okay.
Okay, so here's another possibility though. -2, absolute value 4x minus 7 minus 3 equals, oh, we'll go 5. Okay. So right now it's looking really good, right? It's a positive number. but you have to isolate that. So you're going to add 3 to both sides. Still looking pretty good. But you have to undo this. You have to divide both sides by -2. Now it's not looking so good. How many solutions does this have since it's a negative number?
No solution.
No solution. Okay. So the summary here, let me try and summarize before I give you some problems here, is you're going to have something inside parentheses. We'll say AX plus B, whatever that is, equals C. So if C is greater than 0, meaning it's a positive number, 2 solutions. If C equals 0, so if there's literally a 0 here, 1 solution. If C is less than 0, like a negative number, there are no solutions. Okay, and this is key here. This is what you've got to take away from today's lessons. And it works in really nicely with like x-intercepts and y-intercepts, some of that stuff that we talked about earlier. Because what I want to do now is give you some problems, just like I did here. And basically all I want to know is how many solutions are there? Is there no solution, 2 solutions, 1 solution? That's what I want to know. So you have to solve for the absolute value. Okay, so let me give you your first problem. -3, absolute value 5x minus 9 plus 6 equals -9. I want to know whether there is 0 solutions, 1 solutions, or 2 solutions to this. And you do that by solving for the absolute value right there. You don't have to actually find them. You just have to rearrange the equation. So give that a try, please. All right, what do you say here? How many solutions does this have?
Two solutions.
I'm sorry, did you say 2 solutions? I didn't hear you. That's why I'm asking. Yes. So when you subtract 6, you get -15. You divide by -3 and you get +5. Yes, it has 2 solutions. Perfect. Okay, let's try one more here. Let's say it's the absolute value x minus 5, -2 out in front, +3 equals 3. Does this have 0 solutions, 1 solution, or 2 solutions? So notice that if you subtract 3 from both sides, you get 0 on the right. And when you divide by -2, you keep the 0. And that means you have one solution.
Okay.
All right. Great job tonight. Glad you had a great first day of school, and we got a lesson on Wednesday, so I will see you then. Thank you so much, and hope you enjoy the rest of your evening.
Question.
Yep.
Lesson.
I didn't hear what you said.
Can we move the lesson to either tomorrow night?
I can do it tomorrow, but it will have to be at 6 or, well, I would prefer 6, either 6 or 8, or I guess earlier, I suppose. What do you prefer?
I can do 6. That's perfect.
Okay, it's done. I'll reschedule for 6 tomorrow. Thank you so much. See you tomorrow night.
Okay. Thank you.
You're welcome. Bye now.
Thank you. Bye.